Another type of sequence that we need to know for our National Senior Certificate examinations in grade 12 is actually the quadratic sequence. Now, a quadratic sequence comes from the standard form of a quadratic equation. If I were to write down the standard form of a quadratic equation, we know that it's going to be given by y is equals to ax squared plus bx plus c. This is a standard form of a quadratic equation. From this equation, we literally come up with a general formula for the quadratic sequence. We turn this standard form into a general formula of a quadratic sequence. That means I'm going to write it in terms of Tn is equals to an squared plus bn plus c. What we have done essentially in this equation is that we took the variable y and now are replacing it with the nth term, Tn. Remember, we defined Tn in our introduction to sequences lesson 1. Now, n here which stands for the number of terms. In other words, where we see an x, now we put n. This is to say that the number of terms is a function of the general formula of our nth term of our Tn. The Tn, any term in the sequence, it depends on the number of terms. If we know that number of term, we can find that specific term that we're dealing with. Now, from this, we can actually go and find those terms. Say, for example, if I look at term 1, it means that I'm going to take my equation, the equation Tn is equals to an squared plus bn plus c. And I'm saying T1, that would mean that my n is 1. As I said, n is a variable here that used to be x. So this means we're going to have T1 is equals to, where I see the n, I put a 1 because we're looking at term 1. This will simplify into a because 1 squared is going to be 1. So we're going to have an a there. And any number multiplied by 1 is that number. So we're going to have a b there. And here we're going to have a c. This means that the first term would be given by a plus bn plus c. So here our first term will actually be a plus b plus c. If we then go look for term 2, we will do the same mathematics to say that the Tn will be given by an squared plus bn plus c. So that now I have I put a 2 now because I'm on term 2, and I put a 2 as well here because I'm on term 2. And this would simplify to 2 squared is a 4. 4 times a is just a 4a. And here I'm simply going to have a 2b plus c. Now this means the second term, because this is the second term, the n here is a 2. This means the second term would then be given by 4a plus 2b plus c. We continue doing this to find the third term. We can go on to find the third term of the sequence. Now this would mean again, that will take the same formula that we've been using here to say now we are looking at the third term, so that I'm going to have a 3 to the power 2 plus b times 3 plus c. Remember, I'm putting a 3 here because I'm looking for term 3. Now this would then mean I'm going to have 3 squared to be a 9, and this should give me a 9a, and b times 3 is just 3b, and we have c here. So now this means term 3 would be given by a 9a plus a 3b plus a c. Now we are going to look for the fourth term as well, T4. I'll run the same mathematics here to say T4 is going to be given by a 4 squared plus b times 4 plus c. But we all know that 4 squared is a 16, so that I have a 16a here because a times 16 is just 16a. And here we're going to have a 4b plus a c. This means that our term 4 will then be defined by 16a plus 4b plus c. Now I'm going to stop here because I believe now that you can see the pattern, that if you want any term in this sequence, we use this general formula. So this sequence, you can continue going like that to T4, T5, T6, T7, and so on, becoming an infinite sequence. Now, when we look at this type of a sequence, it's something that, we can test some of the things that we've been doing in the past with an arithmetic sequence. What I mean is that one can be interested to say, okay, what happens if we find the difference between these successive terms? Will we get a common difference here, or what will we get? Because we know by experience now with an arithmetic sequence that we get a common difference here when we subtract these two terms, the successive terms. So we're going to test that out to see the behavior of a quadratic sequence. Well, when we come here and say, for instance, T2 minus T1, which is basically this term minus this term, we can see that here we are going to have a 4a plus 2b plus a c, and it subtracts here the a, b, c. Again, because I have a trinomial inside here, I'm going to put brackets here because this negative will affect each and every term inside there. Now, to simplify this, you can see that we're going to have a 4a plus 2b plus c. We're going to have a minus a, minus b, minus c. Now, if we do our like terms here, we can see that the a and the 4a are like terms. So this would give me 4a minus a, that should be a 3a. And the 2b and the negative b, they're also like terms, so that I'm going to be left with a b. The c and the c are also like terms, and they give me a 0. So we have a plus 0 here, invisible 0 there at the end. Now this then means that our first difference is going to be 3a plus a b. Then we are going to compute the same mathematics here by saying that term 3 minus term 2. Now I'm saying here that this term 3 minus this term 2, 3 minus 2, what do we get? What difference do we get? Now this would be a 9a plus 3b plus c, and we're subtracting here the 4a plus 2b plus a c. So that now I'm going to have the 9a plus the 3b plus the c, and here we are going to have a negative multiplying each term inside the brackets, and this would give me a negative 4a we're going to have a negative 2b and negative c. Now, when we group our like terms, we can see that the 9a goes with the negative 4a. And when we say 9a minus 4a, that gives us a 5. So that means we're going to have a 5a. And if we say the 3b minus the 2b, that should give me a b. And then the c and negative c, there will be a 0. So I'm going to have a plus 0 here, which we don't write. It will be an invisible 0 there. That means the difference between T4 and T3 and T2 is going to be a 5a plus b. We're going to have a 5a plus b. This is the a here. Now, I'm going to continue to find the last difference here between term 4 and term 3. So the difference between term 4 and term 3. I'm going to say here now, term 4 minus term 3. So that I'm going to have now a 16a plus 4b plus c. We're subtracting from it a 9a plus 3b plus c. And we can see at this stage that here we're going to have a negative 9. So we're going to have a 16 minus this negative 9, so that it gives me here a 7a. And we're going to have a negative 3b here, and so that means we're going to say 4b minus 3b. I mean, that should be a b. And then this would be a negative c as well, so that c minus c is going to be just the 0, and then we have a plus 0 there. This means now that the difference that we come up with between term 3 and 4 would be given by a 7a plus b. Now, the results that we got here, of course, because it's a different sequence, there won't be a common difference. It's just that we're inspired by the arithmetic sequence to find this difference. We can see that we get different numbers here. We don't get numbers that are the same as we do in an arithmetic sequence. Interesting enough is that you would see that the b here is always the same. It becomes a constant, and we see the a changes. There's 3a, 5a, 7a, and we can see that the pattern will always be a number times a plus b. There'll always be a number times a plus b. When you go to other terms that you're looking for the first difference here of the sequence. Now, we can be clever enough to say, okay, if we don't see a difference here, perhaps let's go find the second difference. What I mean by that is that how about we find a difference between the successive terms of the first difference, right? Meaning if I subtract this and this, what do I get? Right? And also if I subtract this and this, what do I get? Now we're going to do exactly that here on the side again, to say if we say 5a plus b and we're subtracting here 3a plus b, I'm basically taking this minus that. We can see that we're going to have a 5a plus b, and then we have a negative 3a negative b. This would then give me at this stage the 2a, because 5 minus 3 is 2a, and the b minus b will simply just be a 0, and then I'm left only with 2a. So we are saying that now here we get a 2a. If we compute the same mathematics here to say 7a plus b minus 5b, we then have 7a plus b. We're going to have a minus 5, a minus b. And this reduces down to 7a minus 5b. That should be a 2a, and the b would still give me a 0 there. That means here we also have a 2a. Now that is some interesting results that we get here. It seems to me that when we then find the second difference, meaning when we subtract this first differences that we got, the successive terms between them, we get a 2a. We seem to get a common difference, right? So that's a very interesting thing, because we can then treat this in a way that we do conclusions to say, now if we have a quadratic sequence, we have the second common difference, right? We're going to have the second common difference, because we can see here that if we continue, and if you have time, you can continue just for you to confirm, doing term 5, finding the difference here, then finding the difference here, you would see that always we get a constant number that is given by 2a, right? So we have a second common difference which is given by 2a. So this, we're going to call it d is equals to 2a, to mean that it is the second common difference. But the other thing that we have noted in this sequence is that we have the first of the first difference given by 3a plus b. Now what I mean by this is that, remember, when we are at this point, all these numbers that we get here, we call them the first difference. All these numbers are the first difference. But this number here is the first of the first difference. And this number here would be the second of the first difference. And this number here would be the third of the first difference. So we are noting here that the first of the first difference is actually 3a plus b. It will always be like this. Even the second of the first difference will always be given by this number, 5a plus b, and so on. This will continue just like that. Now, this here means that we are saying here that term 2 minus term 1 will give us this 3a plus b, is the first of the first difference. Now, the other observation that we made is that the first term in this sequence is really defined by t1, because it's the first term really, right? It's t1 and it's equals to a plus b plus c. So this is equals to a plus b plus c. Remember, this will always be the case. All these things that I'm writing here, they will always be defined by this, because we are writing them in terms of variables. They are generalized, right? They're not a specific number. So this means that if we know the value of a, we then can find the common difference. So if, let's say, I say the value of a, for example, is 1 here, then I can find the actual value. I'll say 1 times 2, and that will give me 2. That means the common difference is 2. And because I know a, if I know a, I can put the a here, and if I know the b, I can put the b as well. Then I can find the numerical value of the first of the first difference. And the same would be true to say, if I know a, b, and c, I can put their values there and calculate the actual value of term 1. That's how we can sort of generate that sequence. Just to look at this in terms of using a specific sequence that is given in numbers, I'll just look at an example here where, let's say, for example, we have specific numbers. Like, I'll just choose numbers at the top of my head to say, let's say the first term is a 12, the second term is a 20, the third term is a 30, and the fourth term it's a 42. Right? Now what we're saying is that in this type of a sequence, what you will do is that you would firstly study this sequence to see its properties if they fall under what we have just studied now in a quadratic sequence. So we'll say now, what is the first of the first difference? So this means I would say the 20 minus the 12. Remember that here, this is term 1, this is term 2, this is term 3, and this is term 4. So now I will say the 20 minus the 12, and 20 minus 12 should give me an 8. Then I will say here term 3 minus term 2, which is a 30 minus a 20. I mean, that is a 10. Then I will also say term 4 minus term 3, right? 42 minus a 30. That should give me a 12. And we can see here, as we were doing this in general, that these numbers are different here. Do you see that I have different numbers? The first of the first difference is 8. The second of the first difference is 10. The third of the first difference is 12. Now, I can continue going further now to test if the second difference, because at this point here we're going to get the second difference. Remember, this here is the first difference. It means the number that I get here is the second difference. Now if I say 10 minus an 8, I should get a 2. And definitely also when I say 12 minus a 10, it should give me a 2. So this would mean that my second common difference is 2. We can see that we seem to be getting a common difference of 2 as we go to that direction, right? And my first of the first difference is an 8, and my first term here was given by a 12. Now, another important feature that we should look at before we close this specific lesson is that when we study this quadratic sequence, we can see that here at the first common difference and coming down here, we actually see that this has the same characteristics as an arithmetic sequence. So basically this here can be seen as an arithmetic sequence. This could be the first term, second, third term, and this would be the first difference. If we chop this part here and study it alone, it's an arithmetic sequence. So we are saying here that this point here is actually an arithmetic sequence. So a quadratic sequence basically is made up of an arithmetic sequence here from the first difference to the second difference attached to that original sequence that we have. We can even see it here with numbers, that if I were to give you this sequence from here going down here, if I were to give you this, is exactly what we've been dealing with in our previous lessons of arithmetic sequence. Because here we have the first difference of 2, and it goes like that. So it's like we're taking this and attaching it to this sequence here, and then the whole thing now becomes a quadratic sequence, such that this becomes the first difference and this becomes the second difference. I am showing you this, and I want you to be able to see this, because sometimes in exams they will combine these two sequences so that you study a quadratic sequence and an arithmetic sequence at the same time. So they can give information of an arithmetic sequence and request you to find a quadratic sequence. But we'll look at that as we practice more questions and do past exam question papers. We will do questions following this background to see how to solve problems that involve quadratic sequences.